Hi everybody. So, as Martin said, I'm Luca De Lucchi. I'm working at the Fondazione Edmund Mach. It's an institute in the north part of Italy. Our main duty are connected to agriculture, environment, and food. So we have different centers. We have a research center, a center that supports farmer, a school for IC school, and a farm itself. And we have a lot of colleagues that are doing experiment on the field, testing different varieties, different training system, and so on. And in the past, they were used to collect data on the paper, and after they moved to some Excel file. But all this information were not connected to each other. And a couple of years ago, we started this project to collect data and monitor field in a more scientific and good way, or 4.0 way. So what is DigiAgriApp? DigiAgriApp is a client-server application with a multi-platform client. It's based all with open source solution. So we have a database managed with the PostgreSQL and PostGIS. And we have a web application that is the REST API server managed with Django and Django REST framework and a lot of other smaller Python libraries. And we have right now 3 different clients. One is the multi-platform developer in Flutter, so it can run on Android, iOS, Windows, Mac, Linux without any problem. We have just to compile in a different operating system, and it runs quite smoothly. There is the web admin panel provided by Django. It's provided by default, so we don't have anything to do that. And finally, we have a plugin for QGIS. This is really useful for all the geographical side of the application. This is a little bit the database structure. It's obviously simplified. We have the farm as one of the central unit. To the farm are connected the users, so each user can see only the data of the farm where they are connected. And in the gray box, you can see all the geographical elements. We start from the field. Sometimes fields are divided in subfield, so in a smaller part of field. We have a row and plants. Until yesterday, I was thinking that our application was the only one managing plants, but Marco showed the QWine solution, and they also provide plant elements. Obviously, it's not a really dedicated application. It's just a QField with some more thematic elements behind. Instead of ours is a dedicated application for agriculture. And to all of these elements, you can connect a lot of information. So the material, so crop, which kind of crop, when there was a plant, what is the rootstock, the clone, and so on. All the operation, observation, measurement, treatment, and sensor data and infrastructure are connected to all the 4 elements. Instead, the other, like remote sensing data, are connected only at the field level, because right now you can get data at 5 or 1 meter, 0.5 or 1 meter resolution. So it doesn't make sense to connect the remote sensing data directly to the plant. We have image data. Right now they are connected only to the field and the plant, but it's quite simple to connect also to the other element if it's needed. And irrigation, for example, is connected only to field, subfield, and row. Doesn't make sense until now to connect to the singular plants, because when you put irrigation, you make irrigation for one entire row usually. And one of the other important part is for our colleagues is the sorting data. So we collect especially apple. We work with apple and vine mainly, and we collect all the data from the sorting machine, and we put on the database, and after they make some analysis on the result of weight and dimension of the apple connected to the variety or the training system. So we trust on open source solution. So we choose to use GitLab instead. GitHub is a little bit more known around the world. There are less users, but it's more open. If something happened to the gitlab.com or to the GitHub association, we can take the GitHub code and run on our server, so we don't lose anything. And inside the GitLab service, we have the source code, issue and merge request. We have automated test, until now only for server, but it's the most important side of the application. So we can, every commit we run test and we see that everything is still working correctly. We have the website, documentation and presentation that are running on GitLab. So just we make some updates, we commit, and immediately we get the new element on the online. For the translation, so the application is possible to translate all the different components, and we use Weblate provided by OSGeo. This is a really good service provided by OSGeo. It's not the only one. For example, also the submission of the proposal that you submit at the conference is provided by a service of OSGeo. And we have an instance of Weblate on some OSGeo server, and you can use it. Weblate is a free and open source solution to translate application. For the distribution, we trust on F-Droid. Until now, it's the only way that we provide our solution on the Android system. There are some discussion to stop the capability to provide the application from different providers. So maybe in the future we have to go to Play Store, but we try to stay far from it until it's possible. And for the other platform, we use the GitHub release. So for each release, we compile the version for macOS, Linux, and Windows, and we serve by GitHub release. Few days ago, I'm not really a social guy, but I understand that social is quite important. And so a few days ago, I created an account in Mastodon. Mastodon is a distributed social network, and so if you are interested, you can follow us on Mastodon at the DigiAgriApp account. Now let's see a little bit about the case study. So this was the first user, and there are some colleagues. They start in 2024 because they have previous services, and they collect a lot of information. As I told you, we have a sorting machine that they measure all the apple, and they had a service from 2000 or something like that. It was never updated, and the IT infrastructure say, oh, or you update the service, or otherwise you have to stop it. And they start to look around. We came with this solution. They were really happy. So we are managing 5 farms around Trentino. It's a total of 3 hectares, 20 fields, and more than 20,000 plants. So as I told you, we can collect data of plants. So all these green points are singular plants. For each plant, we have connected the material and a lot of information. So we have 900 unique material or crop. So this means that the unique material are different for rootstock, clone, varieties, or starting date. So we can collect all this information and make a good analysis after. And in 2 years, they collect 144 observations. So observation means that the plant has some symptom. So it could be diseases, could be died, could be they found some animal on it, each kind of observation. The measurement are really more, but because there are historical ones coming from previous analysis, and we collect all the previous information and we put on the database so they can have the entire history of that field. Right now it's used by 7 different users, and they go around the field, they collect the information, they put on the application. And we have around around 1 million data of apple size, weight, color, and so on. And these are quite interesting for them because they are able to say, oh, this variety in this area with this training system is growing really well. And they try to convince or to force the farmer to use this variety and the training system. They study a lot of different kind of training system. They apply, for example, I don't know how many of you know what is a GUIO. It's usually used on wine. It's a training system that you put the plant on the horizontal side, and after the suckers go up and the plant give a good fruit, and it's quite easy to manage with the machine. And they apply the same system to the apple, and they get a really good result. Obviously, there are some differences between the traditional method, but after a couple of years of the plantation, the results are better than the actual system that it's quite common in our region. So this was the previous method. They use an Excel file assigning for each plant a symbol. They put the number of the label and so on, but it was not possible to manage like this. So you have no information about the spatial information was not there. Yeah, you can say there are number of plant, you know which different variety or stuff like that, but it was impossible to manage. I don't know how they can manage this every year. Instead, when we move from this to our system, we found a lot of problem. So they have to map again every field. And now this is the result with the new system. So it's spatialized. We get all the information that they get before, but in a really simple way. They can change the color without any problem, with also observation, measurement, and so on. This is a view of QGIS done by them. So there is one guy that is a little bit more skilled than other. He's able to use QGIS. He knows a little bit of Python, so he can make his own analysis. For example, they have the map of varieties. Before it was not possible to do. Yeah, they know, but they cannot show on public, for example. So, and this is quite useful when you have to do a replacement. We can see it later. Yeah, this is in the left, all the fields that are dying or has to be removed for some diseases. We have some diseases that if the number of plants is higher than 5%, that you have to remove all the plants. It's law, it's applied to apple and vines, and so it's quite demanding, and it's also a big problem for farmers, because if you have to remove completely a field or a plant, is taking time and money. And so they make this map all the dyed field, and in the right side you can see the new field and the year that they think to plant again. So they can also manage the year where there are no plants, to put some some middle plants or small plants to give more power to the soil and so on. They can make the beautiful graphs. They are automatically generated by the server, so just a button, they click on the button and they get the graphs. These are quite new stuff, came a couple of weeks ago. This is the second case study, is in viticulture, so it's completely different species, but the idea behind is the same, the software is the same without any problem. In this case, we have again 5 different farms. It's a smaller area, it's just 2 hectares. But yeah, it's 5 farms and 5 fields because it's a project where they are studying diseases on different varieties, and they need only 1 field for each farm. They are different located around Trentino. We have 7,000 plants. Obviously the vine are closer than apples, so the number increases quite a lot. and 19 different material, and in just one summer they collect 51 observations, so plants that are sick. And especially for them it's quite important to understand if the sickness of the plants are all close to each other, and how the disease are moving in the year. So with this solution they can check every year how the disease distribution is going on. Right now there are only 4 users that are my colleague that are collecting this kind of data. To map all this information, they go on the field, they collect just the number of plants, they prepare a Excel file or CSV file, and after we can create all the plant and the position on the fly with the QGIS plugin. Obviously, it's not at the centimeter scale resolution. It could be a meter or 2 meter resolution, but we don't care at the centimeter resolution in this moment. The importance of this is that the plants are sequentially, because they go on the field with a normal GPS, and they cannot trust on the GPS, they trust on the number of plants. So they say, okay, this is the 4th plant of the first block, and they mark as diseased. And directly on the app, they can see which are, okay, this is the interface of the app. They can see immediately which are the diseased plant, and so they cannot assign twice the disease at the same plant. I think that this is most of the presentation. I need to say thanks to some partner. Obviously, there is a Fondazione VRT that is one Fondazione in Trentino that support research and give some money to develop our idea. We applied for 2 different projects, and in both of them they accept our solution, and with them we increase a lot of the application and the multi-platform client solution. And the second one that I didn't mention before, it was that we have a small part of AI inside the application. So we develop a machine vision system to recognize the Scaphoideus titanus, that is an insect that brings the flavescens doré, that is a disease very dangerous for vine. So if you have too many plants, you have to remove completely the field. And right now we are able to recognize this kind of animal on the sticky trap. It's the yellow sticky trap. There are some traps where the insects go there and they remain glued to the trap. And we collect a lot of information about this trap. And before it was done by hand, so people had to look on the trap and assign the number of animal. Now it's possible to do automatically. And after the other 3 are they are companies that support us to develop the mobile application, because the server side is done by us, mainly by me, but for the client application we have not skill on Flutter, and we trust on these 3 companies. We assign some topic to one or to the other to be sure that if something happened to one company, we have a backup always, and also to provide the money to the entire ecosystem around our area. After that, I learned a little bit of Flutter, so I'm able to modify small part of code, but when we have a big new feature that we want to implement, we trust on them. That's all. If you have any question, and as I told before, if you are in Mastodon and you are interested, please follow us.
Thank you. That's fantastic. Important application. Are there any questions from the audience?
All right, thank you, Chair, and thank you, Luca, for the presentation. I really like what you guys have done here, but I just wanted to have one clarification on the client side, on the mobile app end. Do you have offline capabilities where?
Not yet.
Not yet.
Not yet.
But you have plans to have.
Yeah, but
Okay.
I don't know when it will come because it's
Okay.
not a so simple solution.
Okay.
I spoke a little bit with the Kufi Cloud guy, and they give me a really good spot how to implement it. But this is one of the topics that we have to work with the client, with the company, and we have to find the fund. But yes, it's one of our topics for the future, for sure.
Yeah, I think it would be nice if you can have.
Yeah,
that as well.
especially because one of our topic is to work also in developing country, and I understand that sometimes there are not many connection on that. But usually synchronization of data are not quite simple task. We need to study about that, but it will come maybe in 1 year or something like that. But
thank you for the talk. On the database design slide that you had, you showed that there was image data being stored, and the design is this is all in PostgreSQL and PostGIS. So are you able to actually store image data in the database?
We use Django, and Django is keeping the images outside the database and make the connection. So the images is keep as it is. Instead, we use also PostGIS raster to save some satellite and drone images, and these are saved as PostGIS raster, so they are inside the database. But the images are not saved there. Because for images, they save a blob inside the Postgres, and doesn't make much sense.
Yeah, it doesn't bring much value, right?
Yeah.
Thank you.
You're welcome.
And there was a question, I think, here.
Okay, thank you very much for your very good work. So I have a question about your examples.
Yeah.
How did they update and collect the data, including the crop management and also irrigation, diseases, and so on? Do you use here you showed use remote sensors, use sensors. Did they already use that?
So sorry, let's see this slide. So sensor data are coming. You can connect the sensor. Right now there are two ways to connect sensor to the database. One is HTTP request. It's just a REST API. You can send the data to the REST API. Otherwise, we support MQTT. So MQTT is a standard, or is a format or services for IoT, and we send the data from the sensor with LoRaWAN to the ThinkStack, is a LoRaWAN provider, and they send the data to the MQTT server, and in the server side we have the capability to say I want to listen this MQTT server and topic, and every time the data are sent, automatically are saved on the database.
Okay, thank you very much.
And instead the other operation, observation, measurement right now are saved by the people on the field. Irrigation there is, but is not really used yet.
Okay.
And right now what is not used so much is irrigation and treatment. But the treatment it will start to use next year for sure. And we made some improvement. And about irrigation, I don't know. But I know there is a lot of systems that are automatically sending data. As soon someone asks for any test case, we will see how does it work.
Okay, the two examples I just showed is mainly for fruit and viticulture.
Yeah.
So you manage each plant.
Yeah.
Is it possible to apply this in grain crop like corn, maize, and you?
Sorry, can you
So for other crops like grain, not that high value like fruit and viticulture, it is possible to use
Yeah. It's possible to use with any kind of crop. On the server side, we already save a lot of data. We try to share the data that we use in our database to have a common way to speak of the different DigiAgriApp instances, and we already had the different variety and species already on the server. And there is a Spanish research center that they would like to use for oak tree and stuff like that. So, and
I will.
Sorry.
I think I'll recommend to take this a little bit to the hallway because we need to let the next speaker to
prepare,
line up their talk. It's very interesting talk. Thank you very much again, Luca.
Thank you.